Okay, it should be live. Can someone just check that it's all okay on the YouTube? Content, live, yeah, can someone just check? I'll just paste this in the comments. Yeah, here we go. Can you guys just check that? Oh, video unavailable, playback on others. Oh, okay. That makes sense. Yeah, can you guys just press that link and tell me if it's okay, the audio, or if it's double? Because I see two inputs for audio, so I'm not sure. Just let me know. That'll be good. Um, anyone wants to let me know? Okay, yes, okay, okay, that's good. Okay, okay. So, okay, yeah, that's chill. So let's go through this. So this is what we call a full adder. So if we look at one piece of this here, this bit here, actually, hold on, where is my, if we just take one piece of it, put it over here, this is what we call a half adder. So this here is a half adder. If we input, so if we have different inputs, A here, B here, I would just draw a truth table. This will just say is C, and this is here D. C, D. So A can be 1, 1, 0, 0, 1, 0, 1, 0. These are different inputs. So if we input A here and we input B here, so 1 and 1 is going in, we're going to get 0. This is an XOR gate. So if you just draw this, and the rules for XOR are simple. XOR 1 equals 1. So these are rules for the XOR gate. So that's going to be O. And now we're going to have, we're putting in a 1 and an O. What do we get? This is a D, by the way, for those of you who couldn't tell. It's D. Oh, sorry. This is C. What am I saying? Yeah, this is C. That's D. So 1 and an O, 1's going to come out. O and a 1, 1's going to come out again. Now we have O and a O. O is going to come out here. Next one, we have, sorry, I'm just going to rub these out. I hope everyone knows them down if you needed to. Next one, we have an AND gate. So this here equals AND. So 1, oops, and 1 equals O, O and equals O. So if we do this, we're gonna have 1, 1. Sorry, we're just ignoring this bit. We're gonna come down this route here, put the 1 into there, come down here. This one is going to come down here, come into here. And what do we get out? We get 1. 1 and O. Well, we know that 1 and O is just going to be 0. So I'm not going to just do that whole long thing again. We should know this now. So this is what our truth table looks like. Now, what do we notice about this truth table? Well, it's actually, let's see what happens when we actually look at 1100 plus 1010. Well, 1 and 1, okay, let's start from this side. 1 and 1 equals O, which is the C here, and we have the carry bit of 1. Actually, I'm going to start from the bottom just because it's easier. O and O is O, no carry bit here, carry bit. And we have no out. So this is O. O and 1. Well, we're here now. We have 1 as the output here and no carry bit. Again, O and 1. We have 1 as the output, no carry bit. 1 and 1. We have no output, but we have a 1 carry bit. Does that make sense? So this is our carry bit. Hopefully that makes sense to you guys. Next bit. Now it gets to a bit more complicated. So in what do we mean by lower and higher bits? So let's go over that quickly. So a lower bit and a higher bit. Essentially, all it's saying is that the MSB is higher than that one. Does that make sense? So, for example, I can't really remember how the layout was in the quiz, but it was similar. I think it was like this 001, and then it was 0110 as our truth table. And so all we're doing is we're writing it right to left. So we have 0001 and 0110. Well, this one has a higher bit, like first. So this is going to be our higher bit, and this is going to be the lower one. I hope that made sense. So this actually represents the XOR gate, and this represents the AND gate. Okay, next bit. So now we have half adder and this is a half adder, and a OR gate, which makes a full adder. So so let's try our different inputs. So we have 0, A, B, C. So A, B, C. These are our 3 inputs. So we have 0, 1, and 1. So 0 here, we have 1 here, and we have 1 here. So let's try it. So 0 is going to come into here, and 1 is coming into here. When we XOR 0 and 1, we get 1 as an output here. So we know that E here is going to be 1. So we're going to come down now. 0 is going to, oh, sorry. So sorry about that. So we have A coming in here, goes to here. So it's 0 and 1. So 0 is here, 1's here. What do we get when we AND them? Well, we get 0, so our D is going to be 0. So now we have 1 up here, that comes from the E, so the E is going to be 1. That's going to go here, so there's 1 here. We have C as 1, 1 is going to come across and go into here as 1. This E, we're also carrying upwards, and there's a 1 here. So we have 1 XOR 1, which is going to be 0. And then we have 1, take the C down, which is a 1, and 1, which is 1. We're going to have F as 1. So we have D here as being 0. So D, 0 is going to come into here, and 1 is going to come into here. And what do we get? We get 1 coming out to H. Hopefully that makes sense. You just have to follow it along. I will check if there's any questions now in the chat. So just let me know if you have any questions. I'm just checking it now in no mic. Thank you for the sub. Always appreciate a good sub. Yeah, let's go move on to the next one. So we have I'm trying to keep on any questions as best as I can, so please do let me know in no mic if you have any questions, or in the YouTube comments if you're on the YouTube side. Next question, question 4. I don't know what it means. Let me just see what question 4 is. Let me just get the quiz up. Okay, let me just go through the rest of this and then we'll go to question 4 just in case there was someone who didn't understand this bit. So 1 and 1 and 0. So we have 1 here, 1 here, and 0 here. All we're doing is we're following it along. Sorry, I'm just checking what question 4 was. Oh, 1 moment, please. What do you want? From? Get me a Desi Bird burger. A Desi Bird burger. Yeah. What? A Desi Bird burger. Desi Bird? Yeah, that one. As the one which flies like a pigeon? Yes. Bye. Me or? Just, it comes with chips. No, they just shut the door. So you want it with chips? No, all the burgers come with chips. Bye. Sorry about that. Was gonna turn the audio off, but I don't really know how to do that for this. I'll figure it out eventually. Hello Vix Prime, how are you? Okay, I actually do need to pause the video though, just in case while I take. So, okay. Hopefully you guys can't see the video. Hopefully not right now if you're on YouTube, just because I am doing a little sneaky something. So don't worry about that. But it will come back soon enough. Discord people, you are welcome to keep watching. Obviously we don't cheat here, so there's no cheating. I do not condone cheating of any kind. So we don't cheat. We just explain the content of the quiz. Okay, so question number 5. That's 5. Previous page. Question number 4. Okay. Well, we have to. Okay. Okay, I see what question 4 is now. Okay, that makes sense. Sorry about that. We'll go back to here. Let me just start that stream again, actually. Welcome back, guys. So, yeah, so I just checked what question 4 was. I'll explain that in a second. Let me just finish this off. So now we have, oops, 1, 1, 0. No. So we're taking 1 in here, 1 in here, XOR them, we're going to get 0. So E is going to be 0. Now we're going to take this 1 down here and this 1 down here. 1 and 1 is going to be 1. So we have 1 here. We have 0 here. 0 is going to come up here. 0 is coming in here. 0 XOR 0 is going to be 0, which is a G. Now we have 0 coming down here, 0 into here, 0 and 0 is going to be 0, so f is going to be 0. 0 comes down here, XORed with a 1, 1 XOR 0 equals 1. And now we have 1, 1, and then this is actually a 1 now. So 1 comes in here, 1 comes in here, XOR them, we're going to get 0 at E. Then we're going to bring it down here, 1 and 1. 1's going to come out here, so D is 1. So we're going to bring this E up here, and we have a 1 coming in, 1 XOR equals 1, so G is 1. And then we're going to just bring them down here. 0 and 1 is going to be 0, so we're going to just have 0 in there, 1 in here. 1 or 0 equals 1. F, what did we say F was? 0. Hopefully that makes sense to you. Now, let's see what it's saying. What does this actually represent? So if I just get a new slide up, let's keep all that. So essentially it's just saying, what would happen if we did 0, 1, 1, 1, 1, 1, 1, 1, 1, 1. Is that what it is? Oh, sorry, that's a 1, 1, 0. So 0, 1, 1, 1, 1, 0, and 1, 1, 1. What would happen if we added these together? Well, 1 and 1 is going to be 0, and we have to carry 1. So let's confirm that. So this is what we get out. So if we're taking, for instance, actually I lied to you. That's not how we lay it out. That's not the layout. What it's asking. Sorry. So A is, so if we're adding 0, 1, 1. So this column to this column to this column. So we have 1, 1, 1 here. And then 101. Sorry, that's how it is. So now we're doing 0, add 1, and what? Add 1. So 0, but I'm going to start from the bottom just because it's easier. So we have 1 and 1 and 1. Okay, so we're going to have 1 here and we're going to carry 1. That's how we would normally do it, and let's confirm that. So we should get 1 as an out. Yep, 1 is a result, and we're carrying 1 from H. That's all it's saying. And we just have to verify that these results match what we would get if we added it normally, which it does. So this row is correct. Let's try 110, which is the next one, 110. So when we add it normally, we have 0 here and we're carrying 1. So what would we get here? 110, what do we get? We get 0 as that result, and then we have 1 as a carry. So that's also correct. I'm lying to you. Yes. No? No, I'm not lying to you, sorry. I was not lying to you. Also, note that this is not like, how do I describe it? You see how we had this carry here, we just kind of ignored it. That's because you're actually meant to write it like, how do I don't know, it just ignores these carry bits for some reason. I'm not sure why exactly, but it just does. So let's just try it anyway, because when we get to the end bit adder, you'll understand what happens with that extra carry. So next we have the last row, which is going to be 0, 1, 1. We should get 0 here and carry 1. Let's confirm that. We get 0 as a result, and we carry in 1 here, which is what we wanted. Yep. That's it. That's literally so true. Actually, is it true? Let me just check what the question was actually asking. Oh. YouTube people never saw that. Sorry, YouTube people never saw that. The design gives correct results. Yep, so we tested the inputs and it's true. So for everything we tested, it was true. Now we're gonna go to the n bit adder. Oops. Here we go, n bit adder. So what is this really? Well, essentially all we're doing is we have the A and B input like we had over here. We have A and B input, so A naught and B naught. And then we're just using it as a half adder, and the result we get out of here equals the C input that we have over here. And essentially we're just taking that and putting it into a full adder. And then we're putting in A and B. So this one's B that I was just doing, A and B. And let me just rub out. I can't rub that out anymore. So yeah, and essentially we just keep this, the high is the high from here, the carry bit. So the carry bit is always going to be the high. So this is the AND gate. And the low bit is the result. So let's just try visualize what this actually is saying. So all this complicated jargon is basically, let's just pick some numbers. 1110 plus 0001. Literally, that's it. I'm in study group. Okay, that's it. Yeah, so essentially that's it. These are how many numbers we're adding together, and this is like what we get. So if I just find an example, mums, if we just find some example input, oops, I forgot to start the video for you guys to see, but yeah, sorry, I forgot to share my screen for a little bit. You guys missed out. Sorry about that. Don't worry, I will re-explain that. 1 second, let me just add this example in. I know you guys. I forgot to start it again. I know. 1 second. Okay. Hello, people that missed it. I'm so sorry that you guys missed some of the explanation. But anyways, let me just go over it again. So all we're doing is we're taking, let's say, this input. So we're starting with A3, which is going to be 1. Then we have A2, 0. A1, 1. A0, 0. And then we have B0, well, B3, sorry, as 0. B2 as 1. B1 as 1. B0 as 1. Yep. And all we're doing is we're adding these together. We're doing the binary addition, and this is just like a breakdown of what's happening in this binary addition if we have it like in computer parts. So we take this half adder from here, so we have our A0 and B0, which is 0, 1. So we put 0 in here, 1 in here. Whatever we get out over here is going to be our low, and whatever we get out over here is going to be our high. So 0 XOR 1 is going to be 1. And then we're going to have 0 as a carry bit. So this here has a carry bit of 0, so the high naught is going to be 0. And the low here is going to be 1. And so 1 and high naught is 0. High naught is here. Actually, I'm lying to you. That's over here already filled in. And then we're just going to take this naught that we found and have it as our C input here. And then we have our A and B here, which we're given here. So A1 and B1. So yeah, and essentially we just keep going. So whatever we get as the outputs to these, so our carry bits, we use as a C input. Does that make sense? Hopefully it does make sense. And then so whatever we get out here is going to be our carry bit, and anything from here is going to be our result. That's basically it. I'm not gonna lie with this, but we can go through like the example anyways. So that we know that this one was 1, and then we had 0 to carry. So 1 and 1 is gonna be 0, and we should have 1 to carry. Let's just confirm it. So we're putting 1 and 1 and 1 here. So let's see what we get out. We already did this example. Can you see here? 1 and 1 and 1. So we should get 1 here and 1 here. So that should work. So we have 1 as the result and 1 to carry. So 1 in the result. Yep. And 1. Oh wait, yeah, sorry, I'm lying to you. So it should be 0 is the result and 1 to carry, because here it would come out as 0. No, it's not 1 and 1 and 1. It's this one. Sorry, I was looking at the wrong row. I'm sorry, guys. I was lying to you. It's this row. We're looking at this row. 1, 1, and 1, 0. Sorry, I got confused for a second. So yeah, we have nothing to carry, and we should have 1 as the result. So 1 as a result, and then nothing to carry. So yeah, that's again. I said it the wrong way. 1 as the result, and nothing to carry. I said it the right way. I wrote it the wrong way. Sorry, I just confused myself for a second. Again, I keep writing it wrong. What am I saying? I keep writing it wrong. I wrote it right oh, yeah. Sorry, I don't know. I wrote it right the first time, and then sorry, it's been a long day. Apologies for that. Next one. So we have this 1 to carry, and so we're inputting in here. So A2, B2. So A2 is going to be 0, B2 is going to be 1, and then C is also 1. So is it? This is a 0, by the way. Yeah, it confused me as well for a second. And C is going to be 0. No, C is 1. I'm like, what am I saying? Sorry. Okay, so here A2 is going to be 0 and B2 is 1, so it's 0, 1, 1. So here's 0, 1, 1. We just look in our table, so we have the output should be 0, and this is the result. Result should be 0, and the carry should be 1. Yep, that seems about right. So what did we just say? That the result is 0, so the result here should be 0, and the carry should be 1. Hopefully that makes sense to you. Yep, 1 here and 0 here. Let's go for the next one. C is 1, B A3 is going to be 1, B3 is going to be O, so it's 1, O, and then we said 1, so 101. We don't have a 101 here, so we'll just have to make it ourselves. It should be the same as a 011, I'm not going to lie, but just to show you that. Can't actually, oh, can I erase some of this? So we're going to have a 101, so let's just put 1 and then O here and 1 there, so 1 XOR 0 is going to be 1, 1's coming up here, so 1 here, 1 XOR O is going to be O, so we have O at G, so G is going to be 0, and then we're just going to come down here, 1 and 1 is 1, 1 comes here, and then 1 and 1 here is going to be, sorry, 1 here comes out here, 1 goes in here, 1 XOR, well, 1 and 1 here comes as 1 here, 1 should come out here, so there we go. These are our 2 results. So, yeah, so we should have 0 as the low and 1 as the high, and that is what we get. Any questions about that? We'll go through the next example as well, and we can just confirm that by doing our addition. When, well, it would be false. I don't know when it would be false, I'm not gonna lie. It's just, I guess, not false at the moment. Any questions so far? If there are any questions, please let me know. I'm checking for questions now, so questions, do let me know. Okay, if there's no questions, we'll go for the next example, 0110, 0111. So let's start with our B0, which is going to be 1, and our A0, which is going to be 0. So let's go to our, this one. We're just focusing on this. We had 0 and 1. So 0 comes in here, 1 in here, so 1 XOR 0 is 1 here. This is going to be the lower, this is the higher. So 0 and 1 is 0, so it's just 0 and 1. So the high is going to be 0 and the low is going to be 1. Okay, sorry about that. A bit of cough. Not too serious though. So next one we have coming out as the high as 0. And we have coming in here is 1 and B1 is 1. So 1 in here, 1 in here. So we have 110. Let's see, you can sort our table. We have got a 110. So that's going to have the result as 0. So this is the low, this is the high. So the low is 0, the high is 1. Yep, that's right. So high is going to be 1, low is going to be 0. Next one. So we have coming in A2. So let me just, and B2, 1 and 1. So we have 1 here, 1 here, and we have 1 coming in. So it's 111. And on our table, which is 111, this one's 111. We should have 1 as our result and 1 as our carry. So it's just 1 here, 1 here. So next one, we have B3 and A3. Yep. And one coming in here, so it's O, O, and then 1. Do we have a 001? Let's see. Nope, there's not actually a 001, so we're just going to have to make it. So if we have 0 here, 1 here, let's see what happens. So 0, XOR 0 is going to be 0. 0 comes in here. 0 XOR 1 is going to be 1 here. So we have 1 as G. And then we're going to do 0 here. 0 and 0 is going to be 0. 1 and 0 here is going to be 0. So 0 or 0 is going to be just 0. So we have 0 as the carry. So we have 0 here, 1 here, and 1. And does that work? That seems to have worked. But we can always confirm it. So low 0 I didn't write. Low 1 I did write, but let's just add them up just to see. So we have 1, 1, oh sorry, it should be 0, 1, 0, 1. So I'm just in these from this way and this way. Then we have 1110. Let's add them and see if we get the same result. 0, and we have 1 carry bit. Then we have 1 and 1, which is 0, 1 carry bit. 1 and 1 is sorry, again, looking at the wrong one, but we can just confirm this one too. Sorry, I did the top one. I was meant to do the bottom one. Super sorry about that. I meant to do these ones and this one, so it should be 0, 1, 1, 0. And then we have 0, 111. I was really thinking, why did it not work? Because it should work. 1, 0, no carry bit. 1 and 1 is 0, 1 carry bit. 1, 1, 1 is 1, 1 carry bit. 1 and 0 is 1, no carry bit. So what do we get? 0, 1, 1, 0, 1, which is exactly what we got here. Okay, that's it for half adders and full adders. If that's all you are here for, thank you very much. And I'll check for questions. No questions, that's fine. Let's go to the next bit. Let me just pause the capture here. What? I'm gonna hurry up. What? Okay, so let's get this picture. Let me just see what the questions look like. Okay. Why do I keep doing that? Sorry. Okay, so let me just actually unblind people. Okay, there you go. So we have T1, T2, and we have C. For A as 1 and 0. Is there still audio? I don't know. Hopefully there is, because I heard disconnected from my headphones. Let me just make sure. Okay, there is audio input. Hopefully. Can you guys still hear me?
What, Mom?
Can someone just say something?
Yeah, I can hear you. I can hear you.
Okay, that's chill. Okay, calm. Let's go. So we have 1 as an input. We have, that's it. T2. So when it's 1, what does T? So T2, if it's 1, A is 1. This is closed, and we can go connect to C. So we can say, oh wait, sorry, that's the wrong one. Closed. And then let's try T1. If it's 1, well, it doesn't. It's open, so it doesn't connect. So we're connecting from low. So that's 1. That's coming to C. Sorry, that's not 1. I'm lying. That's 0. Going to C. Next one. Now we're gonna put 0 in and see what we get. So if it's 0, let's try come down here. Yep, we can. This is closed. And this here is open. And what do we notice? That 1 is not, well, not 1 is 0. Not 0 is 1. So this actually is a NOT gate. I think that's what we need to know for this bit. So that's chill. Let me just blind it for a second. Oh, it's also a valid gate. Just want to say that. Now this is a BC, if I might say so. Days. This one is probably the most complex one that you'll see, but let's break it down. So if I actually just break it down further for you guys, we essentially have and then we also have this side. So let's just show you guys each side. So essentially, if we just draw it like we would normally, we have A connecting here, A connecting here, and then this is output to B. This here is the same thing. We have B connecting here, B connecting here, and we have an output to A. That's essentially all it's showing us, this diagram. It's very complicated here, but if we just break it down, we can see that this is where the output line is, where we normally see it, and it connects to this B. And this is where the input is, and that just connects to the A. That's pretty much it. So yeah, if you just want to note that this is the left side, this is the right side. So now let's look at this in a bit more depth. We don't really need to worry about word line right now. Squiggle that out, squiggle out these little bits. Just ignore them for now. Ignore this W1, ignore this W2. Essentially all we have here is the input from B goes into here and here, and this input from A goes into here and here. That's it. That's all we need to know. so it's like a little bit of a closed one. Do you get what I mean? So let's see what happens when we have A and B as different ones. So let's make A as 0 and B as 1. Let's see what the input and output of this would be. So when A is 0, let's see what happens here. So if it's 0, we can have, oh yeah, just so you know that this is 0 connecting from the bottom and it's 1 connecting from the top. So when A is 0, what do we get? We come in here, it connects to B and it makes B 1. Now let's try it. If B is 1, let's see what happens, because 1 is coming into here. So when B is 1, it connects to here, which equals 0, so the output to A is actually going to be 0, because 0 is at the bottom here, and we can only take it up this way to get to A. And essentially, it's going to be switching like this consistently. That's literally it for this. I'm not even gonna lie, it's just a complicated diagram, but once you like break it down, it's pretty okay. If I just like hide my screen once more. So yeah, the one on the left contains transistors T1, T2, the one on the right contains T3, T4, and what we call that little thing that I showed you earlier is actually called an inverter. And it just does like essentially the opposite to what it normally does. Oh yeah, and that also whole thing represents SRAM. That's all you need to know for that bit. Okay, access times. Okay, so let's see what the average time is. All we do is we add these two and divide it by how many there is. So 3 over 2 equals 1.5 ns. Should be lowercase n, sorry. 50 and 70 make 120, so 120 over 2 equals 60. 5,000 and 55,000 equals 60,000. 2 equals 30,000. 5 million add 19 million equals 24 million. Over 2 equals 12 million. NS. Sorry, there's people asking questions. Let me just check. Yeah, I'm just gonna show you how to do the next bit. So if we just have these values, we want to know how many cycles. We're taking it as 2 gigahertz. So this is a 2 gigahertz thing. This should be G. So in 2 gigahertz, we know that there is 1, 2, 3, 4, 5, 6, 7, 8, 9 cycles per second. So that means 2 per ns. So all we're doing is going to times all of these by 2 to get how many cycles per nanosecond. So quite simply 1.5 times 2, which equals 3, 60 times 2 equals 120, 30,000 times 2 equals 60,000. And then 12 million times 2 equals 24 million. Yeah, that's pretty much it for that bit. Hopefully you found it okay. And then obviously you just divide this into that to see how many times more faster it is. Okay, that's it pretty much for this bit. What was the next bit that was a bit, I guess, challenging? I think, oh no. Sorry. Pretty much. I think that's it. Like, that was all that was challenging. This one you just have to pretty much read. I think that's it for today's session. Thank you very much, guys. Commas. I don't actually know. Maybe we do need to include commas. I wasn't sure about that. I don't know. I didn't have admin today, so I wasn't too sure. But I mean, that's pretty much what I have for you guys today. Thank you very much for watching. Yeah, that's it, guys. Oh wait, 1 second. My headphones are not connected, so I can't hear you talking right now. Apologies.
No, I just didn't say anything.
My
Yeah, thank you
headphones
for
are not connected, so I can't hear you. Just type it in the chat, please, if you're talking.
That's tough.
Yeah, I'm gonna stop this then. How do I exit?